Picture Europe 400,000 years ago. A harsh, unforgiving landscape where glaciers advance and retreat in cycles that span millennia, where saber-toothed cats prowl through dense forests, and where survival demands not just strength, but extraordinary intelligence. Into this world stepped a remarkable human species that would not merely survive, but thrive for nearly 500,000 years. If you're using this to fall asleep, that's exactly why I make these videos. So subscribe if you haven't already, and let me know where you are and what time it is in the comments. I love seeing Berlin at breakfast and Boston at bedtime all at once. Meet the Neanderthals. Homo neanderthalensis. A species so successful, so perfectly adapted to their world, that they dominated Europe and parts of Asia for an almost incomprehensible span of time. To put this in perspective, modern humans have existed for roughly 300,000 years, and our entire recorded history spans less than 10,000 years. The Neanderthals were walking the earth for 400,000 years, before finally disappearing around 40,000 years ago. That's longer than our species has existed. They witnessed the rise and fall of countless ice ages, adapted to dramatic climate shifts, and developed technologies and cultures that sustained them through environmental challenges that would devastate most species. The story of Neanderthal survival isn't just about endurance. It's about innovation, adaptation, and a level of intelligence that, in many ways, paralleled and sometimes exceeded our own ancestors. They weren't the brutish cavemen of popular imagination, but sophisticated humans who developed complex hunting strategies, created art, buried their dead with ceremony, and may have even possessed language capabilities remarkably similar to our own. They were the master survivors of Ice Age Europe, and their story reveals secrets about human resilience that continue to shape our understanding of what it means to be human. Recent DNA analysis has revealed that the Neanderthals didn't simply vanish without a trace. They live on in the genomes of modern humans. If you have European or Asian ancestry, you likely carry between 1 and 4% Neanderthal DNA. Their genetic legacy flows through millions of people alive today, a testament to successful interbreeding between our species when we finally encountered each other around 50,000 years ago. Some of these inherited Neanderthal gene variants have proven advantageous for modern humans, helping us adapt to different climates, resist certain diseases, and even influencing aspects of our immune systems. But before we explore their final chapter and integration into modern human populations, we need to understand how the Neanderthals became such remarkably successful survivors. What adaptations allowed them to thrive in some of the most challenging environments on Earth? How did they develop the technologies and social systems that sustained them for 400 millennia? And what can their incredible story teach us about human potential and resilience? The Neanderthal story begins around 400,000 years ago, emerging from earlier European populations that had descended from Homo erectus or related species. Unlike the widespread distribution of Homo erectus across 3 continents, Neanderthals became specialists, perfectly adapted to the specific challenges of Ice Age Europe and Western Asia. This specialization would prove to be both their greatest strength and, ultimately, a factor in their eventual extinction. The first Neanderthal fossil was discovered in 1856 in the Neander Valley near Dusseldorf, Germany, giving the species its name. The discovery caused immediate controversy. Charles Darwin hadn't yet published On the Origin of Species, and the idea that humans had evolved from earlier species was revolutionary and disturbing to many. The thick skull, prominent brow ridges, and robust build of this ancient human seemed to confirm the worst fears of those who rejected human evolution. Here was apparent proof that humans had once been brutish, primitive creatures. But as more Neanderthal fossils were discovered across Europe and Asia, a different picture began to emerge. These weren't failed experiments in human evolution, but highly successful humans adapted to environments that would challenge any species. Their robust builds, large brains, and sophisticated tool technologies revealed a species that had thrived in conditions that modern humans would find extremely difficult to survive. The physical adaptations of Neanderthals tell the story of their environmental mastery. Their bodies were built for the cold. Short and stocky compared to modern humans, with barrel chests and thick limbs, they possessed the ideal body shape for heat conservation in frigid climates. Their large noses weren't just distinctive features, but sophisticated environmental adaptations. The prominent nasal cavities warmed and humidified the cold, dry air they breathed, protecting their lungs and reducing heat loss through respiration. Their skulls housed brains that were, on average, actually larger than those of modern humans. With cranial capacities ranging from 1,200 to 1,750 cubic centimeters, compared to the modern human average of around 1,350 cubic centimeters, Neanderthals possessed the neural hardware for complex thought and behavior. This large brain size, combined with their robust physiques, meant that Neanderthal adults required approximately 4,000 to 5,000 calories per day to maintain their metabolism, significantly more than modern humans. This enormous caloric requirement would have profound implications for their survival strategies and social organization. The skeleton of a Neanderthal reveals the story of a life lived in constant physical challenge. Their bones were thick and dense, with prominent muscle attachment sites that speak of incredible strength. Analysis of Neanderthal arm bones suggests they possessed grip strength far exceeding that of modern humans, with some estimates indicating they could exert twice the gripping force of contemporary athletes. Their leg bones were similarly robust, built for traversing difficult terrain and carrying heavy loads across long distances. But perhaps most remarkably, Neanderthal bones show extensive evidence of healed injuries. Broken ribs, fractured skulls, damaged limbs that had mended and continued to function. These weren't occasional accidents, but patterns of injury consistent with lives spent in close, dangerous contact with large prey animals. Anthropologist Thomas Berger noted that the injury patterns in Neanderthal skeletons most closely resemble those found in modern rodeo riders, individuals who regularly engage in close physical contact with large, powerful animals. Yet these injuries healed. Neanderthals who suffered devastating traumas often survived for years or decades afterward, clear evidence that their societies possessed sophisticated care systems for injured and disabled members. A Neanderthal found at Shanidar Cave in Iraq had suffered a withered arm, blindness in one eye, and a severe limp, yet lived to an advanced age. This level of care suggests not just social cooperation, but genuine compassion, and perhaps even concepts of reciprocal obligation that extended beyond immediate family units. The Neanderthal toolkit reveals the technological sophistication that enabled their long survival. They were the masters of what archaeologists call the Mousterian tool tradition, a technology that remained remarkably consistent across their entire range and timeline. This wasn't technological stagnation, but rather the perfection of a system that worked exceptionally well for their lifestyle and environment. Neanderthal stone tools were created using the Levallois technique, a sophisticated method that required careful planning and precise execution. The toolmaker would first prepare a stone core by removing flakes around its edges, creating a surface with predetermined fracture planes. Then, with a single, perfectly placed strike, they could remove a flake with exactly the desired shape and sharp edges. This technique required not just manual skill, but the ability to visualize the final tool before beginning work, and to maintain that mental image throughout the complex preparation process. The resulting tools were remarkably efficient. A single Neanderthal stone tool could be resharpened multiple times, with some showing evidence of having been modified and reused for decades. They created specialized implements for different tasks: sharp points for spears, curved scrapers for processing hides, and cutting edges for butchering large game. The consistency of their tool traditions across vast distances and time periods suggests sophisticated systems for teaching and learning that could transmit complex technical knowledge from generation to generation. But Neanderthals weren't limited to stone tools. They worked wood into spears, with some specimens preserving fire-hardened points that increased effectiveness against large prey. They created compound tools, hafting stone points onto wooden shafts with plant-based adhesives and sinew bindings. Some sites have yielded evidence of Neanderthal use of bitumen, a naturally occurring tar, to create waterproof bindings and handles for their tools. Recent discoveries have expanded our understanding of Neanderthal technology beyond traditional stone and wood implements. At Abric Romani in Spain, researchers found evidence that Neanderthals were using fire not just for warmth and cooking, but as a sophisticated tool for landscape management. They appear to have deliberately set controlled fires to clear undergrowth, making travel easier and creating environments that attracted the game animals they hunted. The control of fire represents one of the most crucial technologies in Neanderthal survival. Unlike their predecessors, who may have opportunistically used natural fires, Neanderthals had mastered fire creation and maintenance. They could generate fire using pyrite and flint, creating sparks that they nurtured into flames using carefully prepared tinder. Archaeological sites across their range show evidence of sophisticated hearths with stone-lined fire pits, windscreens, and arrangements designed to maximize heat efficiency while minimizing fuel consumption. Fire provided warmth in their harsh environments, but its benefits extended far beyond simple heating. Cooking fundamentally transformed Neanderthal nutrition, making previously indigestible plant foods accessible and dramatically increasing the caloric and nutritional value of meat. Cooked meat is easier to chew and digest, reducing the energy required for digestion and making more calories available for other activities, particularly brain function. The social implications of controlled fire were equally important. Fires created gathering points that extended the active day beyond daylight hours, providing opportunities for tool-making, social bonding, and knowledge transmission. The warmth and light of fires would have made caves and rock shelters more habitable, allowing Neanderthals to occupy sites that would otherwise be uninhabitable during harsh winter months. Archaeological evidence suggests that Neanderthals constructed sophisticated shelters that went far beyond simple cave occupation. At Molodova in Ukraine, researchers discovered the remains of a circular structure built from mammoth bones and covered with animal hides. This wasn't a temporary shelter, but a substantial dwelling that required significant planning, cooperation, and engineering skill to construct. The structure measured nearly 25 feet in diameter and would have provided protection from the harsh Ukrainian winters for extended periods. Similar structures have been found across the Neanderthal range, suggesting that shelter construction was a widespread and standardized technology. These weren't crude huts, but engineered dwellings that maximized warmth retention while providing protection from wind and precipitation. Some showed evidence of multiple occupations, indicating that Neanderthals returned to favored locations repeatedly, perhaps following seasonal migration patterns that brought them back to specific sites at predictable times. The hunting strategies of Neanderthals reveal intelligence and cooperation that challenges any notion of primitive behavior. They weren't scavengers eking out a marginal existence, but apex predators capable of taking down the largest and most dangerous animals of their time. Mammoth, woolly rhinoceros, cave bear, and giant deer all fell to Neanderthal hunters. These weren't desperate attempts at survival, but systematic, planned hunts that required detailed knowledge of animal behavior, sophisticated weapons, and coordinated group action. At Leringen in Germany, archaeologists found a 125,000-year-old wooden spear embedded in the ribs of a straight-tusked elephant. This massive animal, larger than modern elephants, would have been one of the most dangerous prey animals imaginable. Taking down such a creature required not just courage and strength, but careful planning, knowledge of the animal's anatomy and behavior, and precise coordination among multiple hunters. The Schöningen spears, discovered in Germany and dating to around 300,000 years ago, provide direct evidence of Neanderthal hunting technology. These wooden spears, preserved in waterlogged sediments, were sophisticated weapons designed specifically for hunting large game. They were carefully balanced, with the center of gravity positioned for optimal throwing accuracy, and made from slow-growing spruce wood that provided the necessary strength and flexibility. Analysis of these spears revealed that they weren't crude jabbing implements, but precision hunting tools comparable to modern javelins. The craftsmanship required to create such weapons demonstrates not just technical skill, but understanding of physics principles like leverage, balance, and projectile motion. Each spear represented hours of careful work, from selecting the appropriate wood to shaping and balancing the final product. But perhaps most remarkably, isotope analysis of Neanderthal bones reveals that they obtained the vast majority of their protein from large herbivores. They weren't supplementing their diet with small game, fish, or insects, but living almost exclusively on the meat of the largest and most challenging prey animals. This hypercarnivorous lifestyle required extraordinary hunting success rates. They couldn't afford many failed hunts, as their enormous caloric requirements meant that prolonged periods without large prey would quickly become life-threatening. The seasonal rounds of Neanderthals reflect sophisticated understanding of their environment and the behavior of the animals they hunted. They appear to have followed predictable patterns, moving between different sites as seasons changed and resource availability shifted. Winter sites were typically caves or rock shelters in protected locations, often with evidence of long-term occupation and extensive tool manufacturing. Summer sites were more frequently open-air locations near water sources, where they could intercept migrating herds or take advantage of seasonal plant resources. These movements weren't random wandering, but planned migrations that required detailed environmental knowledge passed down through generations. Neanderthals needed to know when and where different animals would be available, which plants were edible at different times of year, where fresh water could be found during drought periods, and how to navigate between widely separated resource locations. The social organization required for this lifestyle was necessarily complex. Successful mammoth hunts required coordinated action by multiple individuals, each with specific roles and responsibilities. Some Neanderthals would need to approach the dangerous prey from specific angles. Others would need to be ready with backup spears when initial attacks failed, and still others would need to manage the immediate processing of thousands of pounds of meat before spoilage set in. This level of coordination suggests sophisticated communication abilities, though the exact nature of Neanderthal language remains hotly debated. Recent analysis of the Neanderthal FOXP2 gene, often called the language gene, shows that they possessed the same version found in modern humans. This gene is crucial for the neural development necessary for complex language and speech. Additionally, analysis of Neanderthal ear bones suggests they had hearing capabilities optimized for the frequency ranges most important for human speech. The hyoid bone, which anchors the muscles necessary for complex vocalization, is virtually identical between Neanderthals and modern humans. Combined with evidence of sophisticated planning, coordination, and knowledge transmission, this anatomical evidence suggests that Neanderthals possessed language capabilities that, while perhaps not identical to modern human speech, were certainly sufficient for complex communication about hunting strategies, tool-making techniques, and environmental knowledge. The geographic range of Neanderthals extended from the Atlantic coasts of Portugal and Spain to the Altai Mountains of Siberia, encompassing virtually all of Europe and much of Western and Central Asia. This vast distribution required adaptation to an enormous range of environmental conditions, from the Mediterranean climates of southern Europe to the Arctic tundra of northern Russia. Yet, throughout this range, Neanderthal populations maintained remarkable cultural consistency, suggesting ongoing contact and knowledge exchange between distant groups. The ability to survive across such diverse environments demonstrates extraordinary behavioral flexibility. Mediterranean Neanderthals dealt with hot, dry summers and mild winters, while their northern cousins faced months of sub-zero temperatures and limited daylight. Yet both populations used similar tool technologies, hunting strategies, and social organizations, modified appropriately for their specific environmental challenges. In coastal areas, Neanderthals exploited marine resources, diving for shellfish and perhaps even hunting seals. Sites along the Mediterranean coast show evidence of systematic shellfish collection, with some caves containing massive accumulations of discarded shells. The diving required to collect some of these marine resources suggests remarkable swimming and breath-holding abilities, adding to the list of Neanderthal adaptations. At inland sites, Neanderthals focused on terrestrial prey, but their hunting strategies varied according to local conditions. In forested areas, they employed ambush tactics, using natural choke points and terrain features to trap prey. In open steppes, they appear to have used persistence hunting, using their endurance and knowledge of animal behavior to exhaust prey over long chases. The technological innovations of Neanderthals weren't limited to hunting tools. They created the first known adhesives, mixing tree resins with ochre and charcoal to create strong, waterproof bindings for their composite tools. This technology required understanding of chemistry that allowed them to create materials with properties superior to any individual component. They also developed sophisticated hide processing techniques that allowed them to create clothing suitable for their harsh environments. While no Neanderthal clothing has survived, the tools they used for hide preparation and the environmental conditions they lived in make it certain that they possessed advanced textile technologies. Some sites show evidence of specialized hide processing areas, with specific tools for scraping, cutting, and softening animal skins. The clothing worn by Neanderthals would have been crucial for survival in Ice Age Europe. Unlike modern humans, who developed fitted clothing with multiple layers and sophisticated closures, Neanderthal clothing was likely simpler but highly effective. They probably wore loose-fitting garments made from carefully prepared animal skins, possibly with fur left on for extra insulation. Recent analysis of wear patterns on Neanderthal teeth suggests they used their mouths as tools for processing hide and possibly for creating cordage. The distinctive wear patterns indicate they regularly held materials between their teeth while working on them with stone tools, a practice that would have been necessary for creating the complex binding and stitching required for effective clothing. The artistic capabilities of Neanderthals have only recently begun to be appreciated. Long thought to lack symbolic thinking and artistic expression, new discoveries have revealed that Neanderthals created art, used pigments, and engaged in symbolic behavior that parallels similar activities by early modern humans. At multiple sites across their range, archaeologists have found evidence of pigment use by Neanderthals, dating back over 200,000 years. Red ochre, in particular, appears to have held special significance. They collected ochre from sources sometimes located many miles from their living sites, suggesting deliberate procurement rather than opportunistic collection. The ochre was then processed using stone tools, ground into powder, and mixed with other materials to create pigments. The purposes of these pigments remain debated, but evidence suggests multiple uses. Some ochre residues have been found on stone tools, possibly indicating that Neanderthals painted their implements. Other ochre stains appear on cave walls, suggesting decorative or symbolic applications. Most intriguingly, some Neanderthal skeletal remains show traces of ochre, possibly indicating body painting or ceremonial applications. In Spain, researchers have discovered what may be the world's oldest cave paintings, created by Neanderthals over 64,000 years ago. These simple red markings on cave walls predate the arrival of modern humans in Europe by at least 20,000 years, definitively establishing that symbolic art wasn't unique to our species. While the paintings are simple compared to later Upper Paleolithic cave art, they represent intentional symbolic expression using pigments that required planning and effort to obtain. Even more remarkably, Neanderthals appear to have collected and modified natural objects for aesthetic or symbolic purposes. Perforated shells found at Neanderthal sites show evidence of being used as beads or pendants. These shells often came from coastal areas far from where they were found, indicating that they were transported specifically because of their perceived value, rather than for any practical purpose. At one site in Croatia, archaeologists discovered eagle talons that had been modified into what appears to be a necklace or bracelet. The talons showed cut marks and polish consistent with being worn as ornaments. Eagles held no nutritional value for Neanderthals, suggesting that these items were collected and modified purely for symbolic or aesthetic purposes. The evidence for Neanderthal symbolic behavior extends to their treatment of the dead. While earlier hominins appear to have simply abandoned their dead, Neanderthals developed elaborate burial practices that suggest beliefs about death, afterlife, or at least respect for deceased community members. The famous flower burial at Shanidar Cave in Iraq, where a Neanderthal was interred surrounded by flowers, suggests ceremonial treatment of the deceased. Multiple Neanderthal sites show evidence of intentional burial, with bodies placed in graves that were deliberately dug and sometimes lined with stones. Grave goods, including stone tools and animal bones, were sometimes placed with the deceased, suggesting beliefs about an afterlife, or at least recognition of the individual identity and accomplishments of the dead person. These burial practices represent a fundamental cognitive leap. The decision to bury the dead requires abstract thinking about concepts like identity, memory, and continuity beyond individual life. It suggests that Neanderthals possessed what anthropologists call theory of mind, the ability to recognize that others have thoughts, feelings, and experiences different from one's own, and that these mental states continue to have meaning even after death. The social implications of Neanderthal burial practices extend beyond simple respect for the dead. Organized burials require community participation and shared beliefs about appropriate treatment of deceased members. The consistency of burial practices across different Neanderthal populations suggests cultural traditions that were transmitted across generations and geographical distances. But perhaps most significantly, the care shown to injured and disabled Neanderthals throughout their lives, combined with the respect shown to them in death, reveals a species capable of compassion, cooperation, and social responsibility that extends far beyond simple survival calculations. These weren't primitive brutes, but caring communities that valued their members as individuals worthy of protection and remembrance. The dietary strategies of Neanderthals reveal another dimension of their remarkable adaptability. While their primary focus remained on large game hunting, evidence suggests they were far more flexible in their food procurement than previously believed. At Gorham's Cave in Gibraltar, researchers discovered evidence that Neanderthals were systematically harvesting marine resources, including mussels, limpets, and even seals. The shells show clear evidence of deliberate collection and processing, indicating that coastal Neanderthal populations had developed specialized knowledge about tidal patterns, seasonal availability, and optimal harvesting techniques for marine foods. Even more surprising, recent analysis of Neanderthal dental calculus, the hardened plaque that preserves on ancient teeth, has revealed microscopic plant remains that dramatically expand our understanding of their diet. Neanderthals were consuming a wide variety of plant foods, including nuts, seeds, roots, and even medicinal plants. At El Cedron Cave in Spain, researchers found evidence that Neanderthals were eating yarrow and chamomile, plants with little nutritional value but significant medicinal properties. This suggests not just botanical knowledge, but understanding of the therapeutic effects of specific plants. The processing of plant foods required sophisticated techniques and tools. Many plant resources are toxic or indigestible without proper preparation. Acorns, for instance, contain high levels of tannins that must be leached out through repeated washing before the nuts become edible. The fact that Neanderthals were successfully exploiting such resources indicates detailed botanical knowledge and complex food processing techniques passed down through generations. At some sites, archaeologists have found evidence of specialized plant processing areas, with grinding stones and other tools specifically designed for preparing plant foods. These weren't opportunistic additions to a meat-based diet, but systematic exploitation of plant resources that required planning, knowledge, and specialized equipment. The seasonal timing of plant exploitation shows remarkable sophistication. Neanderthals appear to have known exactly when different plants would be available, where to find them, and how to process them for maximum nutritional value. This phenological knowledge, understanding of the seasonal timing of natural events, requires years of careful observation and accumulated experience. The cooking techniques used by Neanderthals went far beyond simple roasting over open flames. At some sites, archaeologists have found evidence of earth ovens, underground cooking pits lined with stones, and used for slow cooking large quantities of food. These installations required significant investment of time and energy to construct, but they allowed Neanderthals to extract maximum nutritional value from both plant and animal foods. The earth oven technology reveals understanding of heat transfer, cooking times, and temperature control that rivals techniques used by modern hunter-gatherer societies. The ovens could maintain consistent temperatures for extended periods, allowing tough plant fibers to break down and making nutrients more bioavailable. This wasn't primitive cooking, but a sophisticated food processing technology. Evidence from Kasem Cave in Israel shows that Neanderthals were using controlled fire for food processing as early as 400,000 years ago. The site contains organized hearths with evidence of systematic bone marrow extraction, hide processing, and tool manufacturing. The spatial organization of activities around these hearths suggests planned use of space and coordinated group activities that required communication and cooperation. The bone marrow extraction techniques used by Neanderthals demonstrate remarkable efficiency and anatomical knowledge. They knew exactly where to strike different bones to access the nutrient-rich marrow with minimal effort and maximum yield. The consistency of these fracture patterns across different sites and time periods indicates standardized techniques that were taught and learned within Neanderthal communities. Marrow extraction wasn't just about nutrition, though it provided crucial fats and vitamins during winter months when other food sources were scarce. The techniques also reveal understanding of tool efficiency and raw material conservation. Neanderthals could extract maximum nutritional value from carcasses while simultaneously producing useful bone tools and preserving materials for other purposes. The hide processing capabilities of Neanderthals represent another crucial survival technology. The tools and techniques they developed for preparing animal skins were sophisticated enough to create materials suitable for clothing, shelter construction, and storage containers. Archaeological sites show evidence of specialized hide-working areas with specific tool assemblages designed for different stages of the preparation process. The process of converting raw animal hides into usable materials is complex and time-consuming. It requires removal of flesh and fat, treatment with various substances to prevent decay, stretching and drying under controlled conditions, and often additional processing to achieve desired flexibility and water resistance. The fact that Neanderthals mastered these techniques indicates not just practical knowledge, but understanding of biochemical processes and material properties. Some sites show evidence that Neanderthals were using brain tanning, a technique that uses enzymes from animal brains to soften and preserve hides. This method produces leather that is both flexible and water-resistant, ideal for clothing in harsh climates. The technique requires precise timing and temperature control, further evidence of Neanderthal technological sophistication. The clothing worn by Neanderthals, while not directly preserved in the archaeological record, can be inferred from their tools, environment, and physical adaptations. They almost certainly wore fitted garments that provided effective insulation while allowing freedom of movement necessary for hunting and other activities. The construction of such clothing would have required advanced sewing techniques using bone needles and sinew thread. Recent experimental archaeology has demonstrated that Neanderthal-era tools and techniques could produce clothing comparable to that worn by modern Arctic peoples. The main limitation would have been time and labor investment. Creating a complete set of winter clothing for a single individual would have required hundreds of hours of work, representing a significant community investment in each member's survival. The implications of sophisticated clothing technology extend beyond individual survival to social organization and resource allocation. Communities that invested heavily in creating warm, durable clothing for all members were making long-term investments in group survival. This required planning, coordination, and probably specialized roles for different community members. The evidence for specialized roles within Neanderthal communities comes from analysis of individual skeletal remains and associated artifacts. Some individuals show wear patterns consistent with specific activities performed repeatedly over long periods. One individual might show evidence of extensive hide processing, while another shows patterns consistent with stone tool manufacturing or bone working. This specialization doesn't necessarily indicate full-time occupational roles like those seen in complex agricultural societies, but it does suggest that different individuals developed expertise in different areas and probably contributed to community survival through their specialized knowledge. Such specialization requires social systems that allow for knowledge transfer and coordination of different activities. The manufacturing techniques used for Neanderthal tools reveal understanding of material properties that extends far beyond simple knapping of stone. They selected specific types of stone for different purposes, understanding that some materials were better suited for cutting edges, while others were more appropriate for hammering or scraping tasks. This selectivity required detailed knowledge of geology and material science. At some sites, Neanderthals transported high-quality toolstone over distances of more than 100 kilometers, indicating that they valued superior materials enough to invest significant effort in obtaining them. This long-distance transport also suggests knowledge of landscape geography that extended far beyond their immediate territory. The heat treatment of stone tools represents one of the most sophisticated Neanderthal technologies. By carefully heating certain types of stone to specific temperatures, they could alter the material properties to make it easier to work and capable of holding sharper edges. This technique requires precise temperature control and timing, as overheating destroys the stone while insufficient heating produces no improvement. Archaeological evidence shows that Neanderthals were systematically heat-treating stone tools at sites across their range, indicating that this wasn't an accidental discovery, but a deliberate technology that was widely shared and transmitted. The consistency of the technique suggests standardized knowledge that was taught and learned within communities. The composite tool technology developed by Neanderthals involved combining multiple materials to create implements with properties superior to any single component. Stone points were hafted to wooden shafts using adhesives made from tree resins, creating spears that combined the sharpness of stone with the leverage and throwing capability of wood. These composite tools required understanding of stress distribution, material compatibility, and adhesive chemistry. The bindings had to be strong enough to withstand the impact forces generated during hunting, while remaining flexible enough to absorb shock without breaking. Creating such tools required knowledge that spans multiple technical domains. The adhesive technologies developed by Neanderthals were particularly sophisticated. They created waterproof bindings by mixing tree resins with other organic materials, producing adhesives that remained flexible in cold weather while maintaining strong bonding properties. Some adhesives show evidence of being deliberately modified with additives like charcoal or ochre, possibly to alter working properties or appearance. Recent analysis of Neanderthal adhesives has revealed that they understood the chemistry of these materials well enough to create custom formulations for specific applications. Different adhesive recipes were used for different purposes, with some optimized for strength, others for flexibility, and still others for water resistance. The wooden tools created by Neanderthals, while rarely preserved in the archaeological record, represent crucial technologies for their survival. The Schöningen spears demonstrate that they could create sophisticated wooden implements, but these represent only a small fraction of the wooden tools that Neanderthals must have used regularly. Ethnographic studies of modern hunter-gatherer societies suggest that wooden tools typically outnumber stone tools by ratios of 20 to 1 or more. Neanderthals probably created wooden digging sticks, clubs, handles for stone tools, containers, and construction materials for shelters. The absence of these materials from most archaeological sites is due to decay rather than lack of use. The construction techniques used by Neanderthals for their shelters reveal engineering knowledge that allowed them to create stable, weatherproof structures using available materials. The mammoth bone structures found at sites like Moldova required understanding of load distribution, foundation requirements, and weatherproofing techniques. These shelters weren't temporary expedients, but substantial constructions designed for extended occupation. Some show evidence of multiple building phases, indicating that Neanderthals returned to favored locations and invested in improving their structures over time. This long-term thinking and investment in infrastructure suggests planning capabilities that extended well beyond immediate needs. The heating systems developed for these shelters were sophisticated installations designed to maximize fuel efficiency while providing adequate warmth. Hearths were often equipped with stone reflectors to direct heat toward living areas, windscreens to protect flames from drafts, and ventilation systems to remove smoke while retaining heat. Some sites show evidence of underfloor heating systems, where fires were built in channels beneath sleeping areas and covered with stone slabs. These installations provided radiant heating that continued long after the fires died down, allowing Neanderthals to remain warm throughout cold nights while minimizing fuel consumption. The fuel management strategies used by Neanderthals reveal detailed understanding of different materials and their burning properties. They selected wood species based on their heating value, burn rate, and smoke production. Hardwoods were preferred for long-lasting coals, while resinous woods were used for quick ignition and bright flames. During periods when wood was scarce, Neanderthals burned bone, which produces intense heat but requires different handling techniques due to its distinctive burning characteristics. The systematic use of bone fuel at some sites indicates that this wasn't a desperate expedient, but a planned alternative energy source. The storage of food and materials by Neanderthals required techniques for preservation and protection from scavengers. While direct evidence is limited due to poor preservation of organic materials, some sites show features that appear to be deliberate caches or storage facilities. Underground pits lined with stones and covered with flat slabs may have served as food storage areas, protecting cached resources from both weather and animals. The construction of such facilities required investment of labor in anticipation of future needs, evidence of planning that extended beyond immediate circumstances. The preservation techniques used by Neanderthals probably included drying, smoking, and possibly fermentation of both plant and animal foods. These methods would have been crucial for surviving winter months when fresh resources were unavailable. The knowledge required to successfully preserve foods without spoilage represents another dimension of Neanderthal technological sophistication. The social organization required for food storage and distribution indicates sharing systems that extended beyond nuclear family units. Large game animals provided more meat than could be consumed immediately by small groups, requiring either rapid consumption by larger aggregations or preservation and storage for later use. Evidence from some sites suggests that Neanderthals periodically formed larger aggregations, possibly for communal hunts, social interaction, or seasonal resource exploitation. These gatherings would have provided opportunities for mate selection, knowledge exchange, and coordination of activities across different groups. The timing of these aggregations appears to have been related to seasonal resource availability and animal migration patterns. Sites with evidence of large temporary occupations often correspond to locations where migrating herds would have been predictably available, suggesting that Neanderthal social organization was closely integrated with environmental cycles. The territories occupied by different Neanderthal groups appear to have been substantial, encompassing hundreds of square kilometers and multiple resource zones. The management of such large territories required detailed geographical knowledge and probably coordination between different groups to avoid conflicts over resources. Some evidence suggests that Neanderthal groups maintained relatively stable territories over long periods, with specific sites being reoccupied repeatedly over thousands of years. This territorial stability would have allowed for the accumulation of detailed local knowledge about resource availability, weather patterns, and seasonal changes. The interaction between different Neanderthal populations reveals a complex social landscape that challenges simple models of isolated competing groups. Genetic analysis of Neanderthal remains from different regions shows evidence of gene flow between distant populations, indicating that despite the vast distances involved, there was sufficient contact and interbreeding to maintain genetic connectivity across their entire range. This genetic connectivity required more than occasional random encounters between groups. It suggests systematic networks of contact that allowed individuals to move between populations, probably through mate exchange, seasonal aggregations, or coordinated activities like large communal hunts. The maintenance of such networks across the challenging terrain of Ice Age Europe would have required sophisticated social organization and communication systems. The tools and techniques used by different Neanderthal populations show both regional variations and underlying similarities that reflect this pattern of connection and isolation. Local adaptations to specific environmental conditions created regional tool traditions, while the fundamental technological approaches remained remarkably consistent across their entire range. In some cases, specific innovations appear to have spread rapidly across large distances, suggesting communication networks capable of transmitting new ideas and techniques. The adoption of similar heat treatment techniques for stone tools across widely separated populations, for instance, probably reflects deliberate knowledge sharing rather than independent invention. The evidence for long-distance transport of materials provides another window into Neanderthal social networks. High-quality stone, marine shells, and other materials were sometimes moved hundreds of kilometers from their sources, indicating either direct long-distance travel by individuals or trade networks that passed materials through multiple intermediary groups. Some researchers have argued that these transport patterns reflect the first evidence of trade in human prehistory, with different groups specializing in the procurement of specific resources and exchanging them for materials available in other regions. While this interpretation remains controversial, it would represent a level of economic organization previously thought to emerge much later in human evolution. The seasonal timing of resource exploitation by different Neanderthal groups suggests coordination that extended beyond individual populations. Large animal migrations, for instance, provided hunting opportunities that could support multiple groups simultaneously, but only if their activities were somehow coordinated to avoid interference and conflict. Archaeological evidence from some sites suggests that different Neanderthal groups took turns exploiting the same resource locations, possibly following established schedules or territorial agreements. This kind of resource sharing would have required communication and negotiation systems sophisticated enough to prevent conflicts while ensuring equitable access to crucial resources. The artistic and symbolic expressions found at different Neanderthal sites show both local variations and common themes that mirror this pattern of regional diversity within overall unity. The pigment use, symbolic objects, and cave markings found across their range suggest shared concepts and meanings, while the specific expressions reflect local traditions and preferences. The consistency of certain symbolic elements across vast distances and time periods is particularly striking. The use of red ochre, for instance, appears to have held special significance for Neanderthal populations throughout their range and throughout their existence. This consistency suggests that certain symbolic concepts were fundamental to Neanderthal culture and were transmitted across both space and time through their social networks. The burial practices of Neanderthals show similar patterns of underlying consistency with regional variations. The basic concept of intentional burial appears to have been widespread, while specific practices varied according to local traditions, environmental constraints, and available materials. This suggests that while the fundamental beliefs about death and community membership were shared, their expression was adapted to local circumstances. The care systems developed by Neanderthals for injured and disabled community members represent one of their most remarkable social innovations. The evidence for long-term care extends far beyond the famous cases from Shanidar Cave to include individuals from sites across their range and throughout their timeline. This wasn't an occasional expression of compassion, but a systematic approach to community support that was maintained for hundreds of thousands of years. The consistency of care patterns suggests that support for disabled community members was a cultural norm rather than individual choice. Communities that regularly invested resources in caring for members who couldn't contribute to immediate survival needs were making collective decisions that prioritized social bonds and community identity over short-term efficiency. This care system would have had profound implications for Neanderthal social organization. Communities needed to generate sufficient surplus resources to support non-productive members while still meeting their own survival needs. This required highly efficient resource exploitation and probably sophisticated systems for resource sharing and allocation. The knowledge systems developed by Neanderthals for managing their complex survival strategies represent cognitive achievements that rival those of any human society. Their detailed understanding of animal behavior, plant phenology, seasonal patterns, and geographical relationships required observational skills, memory capabilities, and analytical thinking that operated at the highest levels of human cognitive performance. The transmission of this knowledge across generations required teaching and learning systems that could preserve and communicate complex information without written records. Elder community members would have served as living libraries, repositories of accumulated knowledge about environmental patterns, resource locations, and survival techniques developed over decades of experience. The loss of such knowledge holders would have represented catastrophic losses for Neanderthal communities, creating selective pressure for systems that could preserve and transmit crucial information through multiple individuals and backup systems. The development of ritualized knowledge transmission, storytelling traditions, and systematic training programs would have been essential for community survival. Archaeological evidence suggests that knowledge transmission in Neanderthal communities occurred through structured apprenticeship systems, where younger individuals learned complex skills through extended observation and practice under expert guidance. The consistency of tool manufacturing techniques across generations indicates highly effective training systems that could maintain technical standards while allowing for gradual innovation and improvement. The integration of practical and symbolic knowledge in Neanderthal communities appears to have created comprehensive worldviews that combined survival information with cultural meaning. The use of ochre pigments, for instance, probably served both practical purposes like hide processing and symbolic functions like body decoration or ritual marking. This integration of practical and symbolic knowledge would have created robust cultural systems that were resistant to disruption and loss. Information was embedded in multiple contexts and reinforced through various activities, making it less likely that crucial knowledge would be lost due to the death of individual knowledge holders or temporary disruptions to community life. As Neanderthal populations adapted to changing environmental conditions throughout their long existence, they developed increasingly sophisticated strategies for managing uncertainty and risk. Their toolkits became more versatile, their shelter construction more standardized, and their food procurement strategies more diversified. These changes reflect learning and adaptation that occurred at both individual and cultural levels. The climate changes that occurred throughout the Neanderthal timeline provided continuous challenges that tested their adaptive capabilities. Ice ages advanced and retreated multiple times, forcing populations to adjust their territories, modify their subsistence strategies, and develop new technologies for survival in changing conditions. During glacial periods, Neanderthal populations were compressed into refugia, isolated pockets of habitable environment where they could survive harsh conditions. These refugia served as centers of innovation where populations developed new techniques and technologies under intense selective pressure. When conditions improved, these innovations could spread rapidly as populations expanded back into previously uninhabitable areas. The archaeological record shows clear evidence of technological innovation during periods of environmental stress. New tool types, improved construction techniques, and novel resource exploitation strategies often first appear during challenging periods, and then spread more widely as conditions stabilized. This pattern of innovation under pressure, followed by dissemination during favorable periods, created a ratcheting effect where Neanderthal technological and cultural capabilities increased steadily over time. Each cycle of environmental challenge produced new solutions that became part of the accumulated knowledge base available for future challenges. The final chapters of Neanderthal existence began around 50,000 years ago, when modern humans first appeared in their European homeland. The encounter between these two human species would prove to be one of the most significant events in human evolutionary history, with consequences that continue to shape modern human populations. The arrival of modern humans in Europe didn't immediately spell doom for Neanderthal populations. Archaeological evidence suggests that both species coexisted in the same regions for several thousand years, possibly even tens of thousands of years in some areas. This coexistence period provided opportunities for interaction, competition, and interbreeding that would have profound implications for both populations. The interactions between Neanderthals and modern humans appear to have been complex and variable, ranging from cooperation and interbreeding to competition and conflict. Genetic evidence shows that interbreeding occurred multiple times and in multiple locations, suggesting that the two species were capable of producing viable offspring, and that such matings were accepted by both communities. The genetic legacy of these interactions is still visible in modern human populations. People of European and Asian ancestry carry between 1 and 4% Neanderthal DNA, representing hundreds of thousands of genetic variants that were originally Neanderthal innovations. Some of these variants have proven beneficial for modern humans, particularly those related to immune system function and adaptation to non-African environments. Certain Neanderthal genetic variants appear to provide resistance to specific diseases, enhanced immune responses to pathogens, and improved physiological adaptations to cold climates. The preservation and spread of these variants in modern human populations suggests that Neanderthal genes provided real survival advantages that were maintained by natural selection. However, not all Neanderthal genetic legacy has been beneficial. Some variants appear to increase susceptibility to certain diseases, contribute to autoimmune disorders, or create other health challenges for modern humans. The complex mix of beneficial and detrimental effects reflects the reality that genetic adaptations are always context-dependent, and that changes in environment or lifestyle can alter the costs and benefits of specific variants. The technological interactions between Neanderthals and modern humans also show evidence of mutual influence. Some late Neanderthal sites contain artifacts that show apparent influence from modern human technologies, while some early modern human sites in Europe show evidence of techniques that appear to derive from Neanderthal traditions. The Châtel-Perronian industry, found at several sites in France and Spain, represents a particularly intriguing example of technological mixing. These sites contain tools that combine Neanderthal manufacturing techniques with innovations characteristic of modern human technologies. Whether these represent Neanderthal adoption of modern human techniques, modern human use of Neanderthal methods, or truly mixed cultural traditions remains debated. Some researchers argue that the technological similarities reflect independent invention rather than cultural transfer, pointing out that many innovations might arise naturally from similar environmental pressures and cognitive capabilities. Others contend that the timing and geographical distribution of these mixed technologies strongly suggest direct contact and cultural exchange between the two species. The symbolic behaviors of late Neanderthal populations also show possible influences from contact with modern humans. Some of the most sophisticated Neanderthal art and symbolic objects date to the period of coexistence, leading some researchers to suggest that interaction with modern humans may have stimulated increased symbolic expression among Neanderthal communities. However, this interpretation remains controversial, as it potentially diminishes Neanderthal cognitive capabilities by suggesting they needed modern human influence to achieve full symbolic expression. The discovery of clearly Neanderthal symbolic behaviors that predate modern human arrival in Europe has complicated this narrative and demonstrated that Neanderthals were capable of sophisticated symbolic thought without external influence. The ultimate disappearance of Neanderthals, around 40,000 years ago, represents one of prehistory's great mysteries. Despite their remarkable success over hundreds of millennia, their sophisticated technologies, and their apparent ability to interbreed with modern humans, Neanderthal populations gradually declined and eventually vanished from the archaeological record. Multiple factors likely contributed to Neanderthal extinction, creating a complex web of challenges that eventually overwhelmed their adaptive capabilities. Climate change, particularly the onset of the most recent glacial period, would have compressed their available habitat and intensified competition for resources. The arrival of modern humans would have added new competitive pressures and possibly introduced novel diseases to which Neanderthals had no resistance. The demographic structure of Neanderthal populations may have made them particularly vulnerable to extinction pressures. Evidence suggests they lived in relatively small, dispersed groups that were more susceptible to local disasters and random demographic fluctuations than the larger, more connected populations characteristic of modern humans. Recent studies have suggested that Neanderthal populations were already experiencing demographic stress and declining numbers before the arrival of modern humans, possibly due to climate change and ecosystem disruption. The additional pressures created by modern human expansion may have simply accelerated processes that were already underway. The extinction process appears to have been gradual rather than sudden, with Neanderthal populations disappearing from different regions at different times over several thousand years. The last known Neanderthal populations survived in isolated refugia in southern Spain, and possibly other peripheral areas where they could avoid direct competition with modern humans. These final Neanderthal populations show evidence of increased innovation and cultural complexity, suggesting that extinction pressures may have stimulated adaptive responses even as overall population numbers declined. Some of the most sophisticated Neanderthal technologies and symbolic behaviors come from these late surviving populations, representing final expressions of a remarkable evolutionary experiment. The legacy of Neanderthals extends far beyond their genetic contributions to modern human populations. Their innovations in technology, social organization, and environmental adaptation provided crucial foundations for later human cultural development. Many of the strategies they developed for surviving in challenging environments continue to influence human behavior and capabilities. The compassionate care systems they developed for community members, their sophisticated understanding of environmental patterns, their advanced technologies for food processing and tool manufacturing, and their symbolic expressions of cultural identity all contributed to the foundation of human civilization. Perhaps most importantly, the Neanderthal story demonstrates the remarkable adaptability and resilience of the human lineage. Their success over 400,000 years of dramatic environmental change shows that human intelligence, cooperation, and innovation can overcome extraordinary challenges and create sustainable ways of life even under the most difficult conditions. As modern humans face unprecedented challenges from climate change, resource depletion, and environmental degradation, the Neanderthal example provides both inspiration and caution. Their remarkable success demonstrates human potential for adaptation and survival, while their ultimate extinction reminds us that even the most successful species can be overwhelmed when changes occur too rapidly or challenges become too severe. The 400,000-year reign of the Neanderthals stands as a testament to human ingenuity, adaptability, and the power of community cooperation in the face of environmental adversity. Their story enriches our understanding of human potential and reminds us that success in evolution is measured not just by survival, but by to create meaningful, sustainable ways of life that honor both individual dignity and community welfare. In studying their remarkable journey through time, we gain perspective on our own place in the continuing story of human adaptation and survival.